Hello students, in this video I'll discuss the monotonic sequences and their properties there, and which is the part of sequences chapter, and also which is the syllabus of Karnataka University Mathematics paper 1 BSc Post Sim. So now let us see that is the definitions of monotonic sequences. So that monotonic sequences, what is the definition of monotonically increasing sequence, monotonically decreasing sequence, strictly increasing and strictly decreasing sequence? That. So now let us see that first definition. A sequence xn is said to be monotonically increasing sequence if xn plus 1 is greater than or equal to xn for all n belongs to the natural number n there. It means what here, after if you have a nth number of terms in the sequence, you compare that is the nth term of the sequence, and after the nth term of the sequence, that is xn plus 1, that xn plus 1 is greater than that is the nth term of the sequence, then you can say that is sequence is said to be monotonically increasing sequence. And similarly you can go for that a sequence xn is said to be monotonically decreasing sequence when we compare with after nth term of the sequence, that is xn plus 1, that should be that is less than or equal to the nth term of the sequence xn for every n is member of capital N. It means natural number n. It means that, so if you compare that is the n number of sequence xn, that should be the greater than or equal to, that is after nth number of terms, that is xn plus 1. So then you can say that sequence is said to be monotonically decreasing sequence. So next, a sequence is said to be strictly increasing. It means only that is xn plus 1 is greater than xn for all that small n is member of natural number n there. And similarly for a sequence xn is said to be strictly decreasing if xn plus 1 is less than xn for every small n is member of n that. It means n belongs to n. Then only we have that, we can say that sequence is said to be strictly decreasing sequence that. Next we shall discuss that is the properties of those monotonic sequences. In the first property, a monotonic increasing sequence bounded above is convergent. It means proof of this monotonic increasing sequence bounded above is convergent. So let us take xn be a monotonic increasing sequence which is bounded above. Now let us take capital M be the least upper bound of that sequence xn. That means therefore xn should be less than or equal to that's positive number capital N for every number of n small m is the member of natural number n there. That means, so for every epsilon is positive, there exists another number, positive number small m, this belongs to natural number n, such that xm is greater than m minus m epsilon there. It means that there exists this xm also that in that term, that xn term. So that's why xn is greater than m minus epsilon there. Since as we know that sequence xn is monotonically increasing, so now we have compared with that is the after the mth term, that is xm plus 1, it should be greater than xm. So for every n there, for every n, it is the relation holds there. Therefore That means so that xn should be greater than or equal to xm. It means as we know that monotonic increasing sequence, so that is what we have xm plus 1, it should be replaced by xn, so that it should be greater than or equal to xm. So now we are having that compare with this xm with xn, that xn is greater than xm, and as we know that xm is greater than m minus epsilon, for every n should be greater than or equal to small m. Now you can see that what is the xn there, what is the xn, and as well as that xm and xn also that. So keep remember here, so that xm is greater than m minus epsilon, and also it is greater than m minus, xn is also greater than m minus epsilon, and that should be less than or equal to small m and less than or equal to m plus epsilon. For every n should be greater than or equal to small m. And now we can see that sequence, nth number of sequence, that term should be lies between the m minus epsilon and m plus epsilon for every n is greater than or equal to m. That means if it is sequence is oscillating between them, it means what, here there is a small enough to have that epsilon, so that means modulus of xn minus capital M should be less than epsilon. It means for every n should be greater than or equal to m, that is limit of xn as n approaches to infinity, it gives that is m. It means what? So that capital M, which is a least upper bound, means what? It is the least upper bound of that. So that's why this supremum of that, so that it is the conversion to that bounded above that sequence, monotonic increasing sequence bounded above, which is again a conversion. So then monotonic next property we have there, that is monotonic decreasing bounded decreasing sequence bounded above below is convergent. It means every monotonic decreasing sequence which has bounded below which is again it is a convergent. We wanted to prove it here. So now let us take xn be a monotonic decreasing sequence which is bounded below. Let small m, we treat it as this is the greatest lower bounds of that sequence xn there. So according to that greatest lower bound of that, so when we compare that is the m here, that nth term of that sequence and greatest lower bound, it is the xn should be greater than or equal to small m for every n belongs to n. That means it is the definition of that. So that is for every epsilon is greater than 0, there exists a small m should belongs to capital N, such that that xn is compared with that is see that xn is less than m plus epsilon. Since as we know that since the given sequence is monotonically decreasing, we have that condition for monotonically decreasing, that is the xn plus 1 should be less than or equal to xn for every n. So that means xn plus 1 is that is the xn. When you compare with that, see that xm there. So because xn is always less than or equal to xm, so that is xn is less than or equal to xm whenever that is n should be greater than or equal to m only. That is a provided result. So therefore now I compare with that xm is that is the m plus epsilon there. That is simply it is what it is the xm that it is a misprinting, that is xm there. So that is xn is less than or equal to xm, that should be less than or equal to m plus epsilon. So that means what? It is the it is m minus epsilon. This xn, it is always, as we know that it is the greater than or equal to m. It is the definition of that. We have assumed that here greatest lower bounds, and this xn when we compare with that, it should be less than with xm, and again this xm is compared with this here, that is m plus epsilon. So that means m minus this xn is lies between m minus epsilon and m plus epsilon. It means xn modulus of xn minus epsilon should be less than epsilon for every n should be greater than or equal to m. Therefore, limit of xn as n approaches to infinity, which is m there. It means limit conversion, that is a monotonic sequence is decreasing sequence, so that is which is bounded above, which is again a convergent that. So now a monotonic increasing sequence which is not bounded above, which diverges to plus infinity. So now let us see the proof of this here. Let xn be a monotonic increasing sequence which is not bounded above. It means therefore for every capital K which is positive, however it may be large, that we compare with xm, this should be xm is greater than that K. So for some m belongs to capital N, and also we have that is sequence xn is monotonic increasing, which implies that xn should be greater than or equal to xm. So whenever that n should be greater than or equal to m, therefore this xn is greater than k. Since it is that, so this xn is greater than k. When you xm is greater than k, for every n should be greater than or equal to m. It means what? Limit of xn as n approaches to infinity, since k is very large, so that it is very large, it means what? It is goes to plus infinity. So that is limit of xn as n approaches to infinity, it is infinity. So hence sequence xn, monotonic increasing sequence, which diverges to plus infinity. A monotonic decreasing sequence which is not bounded below, which diverges to minus infinity. So let us take let xn be a monotonic decreasing sequence which is not bounded below. Means what? We can take instead of for every k greater than 0, we take it that for every less L, capital L should be less than 0. It may be, it is, however it is very small, that is means xn should be greater than or equal to L. For some small m is member of capital N, means a natural number, and xn is monotonic decreasing implies that xn compare with xn is less than or equal to xm whenever that is up to n is greater than or equal to m there. After the nth term only that. So that means, so therefore xn should be less than n, because since xm is greater than or equal to m L, so that's why for every after n is greater than or equal to m there. So therefore limit of xn, which is small, however since L is very small, it is goes to minus infinity. So then this implies that sequence xn which diverges to minus infinity. That means a monotonic sequence which is not bounded below, which diverges to minus infinity. Next we shall see some examples here. Show that the sequence xn where xn is, that is n into n plus 1, is monotonically increasing. Just let us take that is a given sequence xn, and also we have a n plus 1 here in that, and consider that is the between the difference of these two, whether it gives the greater than 0 or less than or equal to 0, that depends on that. Xn plus 1 minus xn, when we simplify that, so it should be greater than 0. So therefore after the nth term of that sequence, that should be greater than xn, nth term of sequence xn. So that is for every n. Therefore it is this sequence is monotonically increasing. Similarly you can have that is another sequence there, n plus 1, that xn is n plus 1 by n, and xn plus 1 is 1 plus 1 by n plus 1. When we compare with that, it is what here, xn plus 1 is less than xn. Therefore only if since equality is less than, so that it is strictly decreasing, therefore it is monotonic. And similarly for this it is also some more examples we'll discuss in the next video.